Hello guys, it's me again. I'm Mr. Go. So today I'm going to go through the integration of tangent times secant, the idea behind it. Okay, so maybe slightly different from the way the notes present. Okay, I hope through my explanation with some shortcuts and methods you'll be able to understand it better, and also is convinced that my method maybe help you a bit. So let's begin. Okay, tangent mx times tangent secant nx. So first we look at it. Okay, there are two ways we can look at it. So the first way, first you try to extract secant x and tangent x dx here. Okay, that's the first step. Okay, then second step, after this you may need to use this formula, our favorite formula. Okay, this formula, our Trigo identity, to simplify what is inside the bracket to become f function secant x. Okay, the idea is function, that means it can be secant square x plus secant x, or can be secant cube x. So the idea of function means can be all the different function of secant, all the different function of secant has to be inside this bracket if possible. If not possible, that means this method we have to use the second way, that is here, or alternative. Okay, so after this step, what should we do? Okay, after this step, okay, we will do the substitution now. We do the substitution. We say let, okay, so oops, okay, let me redo this part again, sorry about that. So we say let u, okay, the u substitution equals to secant x. Okay, then u du dx. Now secant x you differentiate, will become secant x times tangent x. Okay, secant x times tangent x, then dx will be du over secant x times tangent x. So that is our normal way of doing substitution, right? Remember? So this is tangent x. Okay, now you put inside the question. Okay, so this part will be having fu, because secant x, this is secant x, remember? Secant x is u, so become fu. So after that you put in, and then this is your this is the question. From the question, this is your ds. Remember, this is your ds. Okay, let me string a bit. That's your ds. Okay, so after that you can just normal integration. Here will be normal integration. Okay, so that's the first step. That's the one alternative. Now the second alternative, I'll go to the second one. Now if you can't do this, not possible to achieve which one? This step, this is the important one, must be able to achieve this. If this is if this is not possible, if not possible, Okay, then you have to use the alternative. Use this. Okay, use this method. So then you have to do your own. So now this method is almost the same, except you focus on getting secant square out from the expression. So again, you simplify from here. You simplify using this formula. Again, our identities. Okay, to get f tangent x. Okay, so you can start with the left side, left method, then go to the right method. So after this, what happens? Same thing. We'll do the substitution. Okay, so we let u equals to, so u equals to tangent x, then du dx, then dx. So replace. Don't forget your u is tangent x. Remember, your u is tangent x. Okay, we already defined u is tangent x. Let u is tangent x here. Remember. So tangent x. So again, we cancel off. This is your dx. So this is your dx. So again, here will be a normal integration, right? Normal, our as per normal integration. Okay, so in this way we can do the question. We can integrate tangent mx times secant nx dx. Okay, I hope you understand the idea behind it. So the example I will show you. We can go to the next example, the example 25 in your text. So okay, hi guys, I hope you are ready for the examples. So here it goes. Secant 4x 3x times tangent square 3x. Okay, we are going to integrate this. Now recall, this is our approach. So if you have this integration, Trigo for secant and tangent, you can try to factor out secant tangent x from the question. So from the question, you try to get this. That's the first step. Okay, then whatever inside here, you simplify to get secant x, function of secant x, using your Trigo identities. 1 plus tangent square x equals to secant square x. Okay, so that is the approach. So you have to use this. So if you are able to get f secant x inside the bracket, then we can continue this approach by substitution. So we say let after this u equals to secant x, and here solve by substitution. So here the whole approach will be integrate by substitution. Okay, use substitution. Now if this is not possible, that means if you can't get this, if it's not possible to get this whole thing, that means more or less if you can get secant x, tangent x out, but you cannot achieve this, could not obtain function of secant x only. Must be only secant x, no tangent, no other thing, only secant x. So secant x only. Okay, if you cannot, then you have to you have to go to this. This is your. So the next approach will be this. If cannot, then you have to try the alternative. So similarly, you have to do something. So you have to get secant square out. That's the first step. Same thing like previously, but previously was secant x times tangent x. Now is secant square. Okay, same thing. Second step is here. This is your second step. So using again identity is 1 plus tangent square x equals to secant square. Okay, so you try to get what? Try to get this f. So here objective is to get the function of tangent x. Same thing. Similar to the previous method. Only tangent x. Okay, only tangent x, no in the function. Okay, that means you cannot have secant x or this thing. You can have tangent square, but you cannot have secant. Any secant terms inside, that means this method cannot work. Okay, you have to try to any secant term, you have to use this formula first. If this formula cannot be used to convert all the secant to tangent, then this method also cannot be used. Okay, so similarly after this we have to integrate by parts again. So after this, you say let u equals to tangent x, correct? After this is that. So you do your working, and then the whole thing, the whole process here is integration by substitution, right? Okay, so we understand. So now let's go back to the question. So the question is integrate secant 4 3x tangent square 3x dx. Okay, so I'll focus. So first we try. So these are side working. You may or may not need to show. So you bracket up this one, you put secant x tangent x, right? So first you try this. Now that means this is really secant cube x, secant cube. There's a 3 here, so secant 3x tangent 3x. Okay, then inside this bracket will be tangent 3x, right? So objective, convert all this to secant x, convert all to secant x. Secant 3x using identities 1 plus tangent square x equals to secant square x, right? So this is the method. So you know it's not possible. So this is already secant cube, so no need to care. So all you need to know is now tangent 3x is cannot be converted to secant 3x easily. Okay, understand? So we don't use square root or cube root, although it's possible, but no root is involved during the conversion. No root. Power can, but no root. Okay, so root is not considered in this solving. In this to integrate this, any root occurred will not be able to resolve the integration. So then, since this failed, so we try the next one. So try not possible. So you write like that again, secant bracket, then the last one will be secant x dx, right? Remember, secant x dx. So to get secant x dx, you have secant square 3x and tangent square 3x. Now what's our objective? Okay, objective is to convert to have only tangent x, right? At tangent 3x, which is possible because there's a square. See, there's a square can be converted, right? Because of the identities, there's a square, so this one has a square. So using the identities, so now we can write, so equals to integrate. Now using the identities, you know, it's 1 plus tangent square 3x, correct, times tangent square 3x, then the whole thing secant square 3x dx. Okay, sorry, this is 3x. Understand? Now you observe, okay, here. So you observe that here are all tangent. So inside this bracket are all tangents. All are tangents. Okay. So all tangents. Oh, it means what? That means pass. We can continue. Okay. So we continue. So become tangent square 3x plus tangent 4 3x bracket secant square 3x dx, right? So now we can use a substitution. So we let u equals to tangent 3x, so du dx will be equals to secant square 3x times 3. So get 3 secant square 3x. So you make dx the subject, so dx become du over 3 secant square 3x. So what next? Now is the substitution, right? So therefore integrate, right? Go back to the question, tangent square 3x plus tangent 4 3x secant square 3x dx will be equals to integrate. Now this is your u, so u square plus u4, right? Secant square is just leave it there. So dx, remember dx is du over 3 secant square 3x, right? That's what. So these two can cancel. Okay, so you get something like that, equals to, now the 3 can take out 1 over 3, integrate u square plus u4 du. So 1 over 3 u cube over 3 plus u 5 over 5 plus c. Now what is u? U is tangent 3x, right? So equals to, take out the common factor, 1 over 15. So take out 5, u is tangent 3x. Cube plus 3 tangent 3x 5, right? Of course, plus c. So the next you can take out tangent square, right? Square 3x over 15 cube tangent cube 5 plus 3 tangent 3x. You can put tangent square 3x the same if for Trigo, plus c. Okay, so this is the full solution for the example. Okay, excluding the so-called the testing, the trying procedure. So here is the one. Okay, so I hope you understand now how you can integrate secant tangent integration. Okay, so the next lesson I will introducing how to integrate cotangent and cosecant. So I'll see you again. Thank you for your attention.